So today we're going to learn 7.3 zero negative exponents. So using zero negative exponents to simplify expressions. Tomorrow we're going to do a quiz review and we're going to take a quiz on Wednesday. So I asked you to do these warm-up questions. So let's see how you did. Number 1, Max. Did you try it? No, just say what you put. So, couple of things. Would anyone like to correct one thing? Brock? For what? For what? The x, yeah. So it should be 9x squared. And then, what's the other thing that he messed up on? Yes. Max, since the exponent was even, the negative sign should cancel out. So it should be positive 9x squared. And since the negative was in the parentheses. Okay, number 2. Kevin? Good job. That is perfect. If you said 2 to the 5th, you can simplify 2 to the 5th as 32. And then for number 3, it says about how many times as great is the sun's mass as Earth's mass? Lydia. Good. So you do 10 to the 33rd divided by 10 to the 27th and subtract the exponents to get 10 to the 6th power. Okay. So the rules for today are, the first one is the zero exponent property. It says anything to the 0 power is always 1. So if you have 5 to the 0 power, the answer is 1. If you have negative 5x squared y to the 7th to the 0 power, the answer is 1. So anything to the 0 power is 1. And then a negative exponent. All of our final answers with exponents should have positive exponents. If you have a negative exponent, you need to make it positive by taking the reciprocal. So a to the negative n is the reciprocal of a to the nth. So a to the negative nth, you could write it as 1 over a to the positive nth. For this one, I like to do it in reverse. If you have 1 over a to the negative nth, which means if your negative exponent is in the denominator, then you just move it up to the numerator to make it positive. Okay, so with 2 to the negative first, that would be 1 over 2, because you move the 2 to the denominator. If you had 1 over 2 to the negative first, then the answer would be positive, or 2 to the positive first power. So you just move the 2 up to the numerator. And then there's nothing left in the denominator. It would just be a 1 like that, but you don't have to put the 1. Okay, so let's do some more examples. Number 1, 3 to the negative second. We would do the reciprocal to make the exponent positive and write that as 1 over 3 to the positive second. And I know what 3 squared is. That's 1 over 9. So 1/9. Number 2, since the negative 7 is in parentheses to the 0 power, the answer is what? Ferris? 1. Yeah, 1. Okay, number 3. It has a negative exponent and it's a fraction in the parentheses. So to make the exponent positive, you take the reciprocal of the fraction. So what's the reciprocal of 1/5? Xander? 5. Yeah, so write that as 5 and then now make the exponent positive, which is 25. So anytime you have a fraction to a negative exponent, you can just flip the fraction around. Just do the reciprocal of it. Okay, number 4, Brock? Not quite. You're thinking if it's 0 to the 5th power would be 0, but if it's negative 5th, we have to flip it first. So 1 over 0 to the 5th power. And if you have 1 over 0, then that's undefined, because you can't have 0 in the denominator. So you'll see a couple ones like that on your homework where it's a negative exponent, so you put the 0 in the denominator. 0 in the denominator means undefined. For number 5, negative exponent means you flip it, so we're going to put 6 squared in the denominator, 1 over 6 squared. And we just put the 1 there as a placeholder for the numerator, since there wasn't anything else left in the numerator. Anyone want to try number 6? Oh yeah, we could have. We could have put 1 over 36. Xander?
3 squared would be 9 over 2.
Close. What needs fixed?
9 over 4.
Yes, because you have to square the 2 also. So first it would be 3/2 squared. Don't get rid of the parentheses yet until you square everything in the parentheses. So it should be 9 over 4, not 9 over 2. All right, I'll give you a minute to try the you-try questions. Put your answer number 1 on the board. Put your answer to B on the board. Yeah. Put your answer to C on the board. You could write that as 1 over 64 for part B. It'll tell you if it does. It'll say simplify all coefficients, and that means that you should write it as 1 over 64. But if it says to write your answer using positive exponents, then it might let you do 1 over 8 to the 2nd power. Good, so those are the answers for those. Do you have any questions? So this one is 1 over 64, 8, and 1. What?
8 squared.
8 squared is 64.
Yeah.
And then it's positive 2. James, you good?
Yeah.
Okay.
I got it.
So for C, it's a negative exponent, so you move it to the numerator. So 2 to the 3rd power is 8. If the negative exponent is in the denominator, you move it to the numerator to make it positive. Okay, you can flip your pages over. Now we're going to put it all together. So we learned the basics of 0 and negative exponents. Now let's apply it with the things we learned before break. Because you're probably thinking in your head, I don't remember anything from what we did before break. And I'm sure you're exaggerating, but we will definitely practice and review the things that we learned. Okay, so for number 1, anytime you have a power times a power with the same base, you add the exponents. But you keep the base the same. So we're going to keep the base the same, but add the exponents. So negative 4 plus 4 is 0. Oh, look, what do you know? It's 6 to the 0 power, which is 1. So the answer is 1. Number 2, anytime you have a power raised to another power, you multiply the exponents together. So for this one, you add exponents. This one, you multiply exponents. First of all, if you square the negative, it becomes positive. And then negative 2 times 2 is negative 4. So 4 to the negative 4th. But now we need to make it so that it doesn't have a negative exponent. So we'll take the reciprocal and write it as 1 over 4 to the 4th. And you wouldn't have to simplify that. If it was 4 to the 3rd, then you would, because 4 to the 3rd is up there on the board on one of the perfect cubes. But 4 to the 4th, you could just leave it like that. And then number 3 is like the you try problem, part C. To make it positive, you just put it in the numerator. Positive exponent. So 3 to the 4th power, and you could just leave it like that if you want, or if you know that it's 81, you can write it as 81. Okay, so for number 4, you see how you have a negative exponent with the 5. That means that we need to bring it down to the denominator. So 1 over 5 to the first times 5 to the second. Since there are already 2 5s in the denominator and we're moving the 1 5 down, how many 5s do we have in the denominator now? How many? 3. So you would write it as 1 over 5 to the 3rd power. And because here you would add the exponents. So that's 1 over 5 to the 3rd. So I move this down here. So this 5 added with the 2 that were already there. I will move it up a little bit. Okay, for number 5, this is like number 1. The bases are the same, so you just keep the base the same, add the exponents, which would be 0, and the answer would be 1. For number 6, I like to think about canceling instead of subtracting exponents, because if you subtract, then you get a negative. If I have 3 7s in the numerator and 5 7s in the denominator, you can cancel these 3 7s, and then how many 7s you have left over in the denominator? 2. So it would be 1 over 7 squared, which is 1 over 49 if you want to keep simplifying it. Okay, any questions? So do the you try questions now. Can you put your answer to A on the board, please? Yeah, put the A on the board. Can you put C on the board? Put D. So tiny. Rather hold it. People back here might not have glasses. Good job. Any questions? 1 over 6 to the 4th is bring the 2 6's up in the numerator, down, add with the 2 6's in the denominator. And then you get whatever 6 is. Questions? You get them all right? Oh, you're trying these ones now. Ooh, yeah, that's right, but we can combine it into like 1 fraction. So just put those 2 things up there instead of 1.
Wait, A wouldn't be a fraction, it'd just be 4/3. I mean, 4 over 3.
What? 4 to the power of 3?
Are those right?
Yes, those are all right. Those are all correct. Actually, let me write the answers here. 4 to the third, which is also 64. And then 5 to the third power, which is 125. 1 over 6 to the fourth. All right. Now, level 2. There might be a question or two like this on your homework, but there won't be anything this hard besides part A. So for part B, C, and D, those might be questions more that would be on a bonus question on your quiz. So I don't want anybody like leaving and crying because they think it's all going to be like the last 3 examples here. All right, let's look at part A. Did I skip anything? No. Okay. So I'm going to raise everything in the parentheses to the third power. So 2 to the third power is 8, x to the third, and then y to the negative 15th. Now, we can't have a negative exponent, so we need to move the variable that does have a negative exponent to the denominator. I don't have a fraction right now, so I'm just going to make a fraction bar and draw an arrow for the y because I'm going to move it to the denominator to make it positive. You're only moving the part that has a negative exponent, though. So you leave the 8 and the x cubed in the numerator where they're at, and then you bring down the y and make it positive 15. For part B, this is where it gets a little bit tricky, so just pay attention. For part B, you see the parentheses here. That's the first thing I'm going to deal with is distributing the exponent. So 2 to the negative 4th times x to the negative 2nd, y to the 5th, over negative 4x squared, y squared. Okay. Oh, I didn't mean negative 4th. I meant negative 2nd. I did that for the other class too. So the 2 up here that has a negative exponent, we need to bring it down to the denominator. What will it be when it comes down to the denominator? Yeah, negative 2 to the second, which is 4. It'll become 4 when it comes down. So, but there's already a 4 that's there. So you would multiply the 4 that we bring down with the 4 that's already there. So it would become negative 16. So draw a fraction bar. This 2 squared comes down and multiplies with the 4 that's already there, so negative 16. Okay. The x to the negative 2nd also comes down and adds with the 2 that are already there, so you would have x to the 4th. Now let's look at the y's. You have 5 y's up here, 2 y's down here. Both 2 of these y's will cancel with 2 up here and leave you with how many left over? 3. So that means the numerator will have y to the third. And then that would be the final answer. That one's a little bit of a doozy to wrap your head around, but just take it piece by piece, coefficient, and then each variable one at a time. Okay, C is very similar to D. So we're going to try C. I'll let you try D on your own. So first we look at the coefficients. 4/8, think about that as a fraction. What is 4/8 reduced to? 1/2. So this would be 1/2. And then, so I'm going to go ahead and put a 2 down here for the 1/2, and then a 1 up here. And then the x squared comes down, but there's already an x there. So how many x's will we have? X to the what power? Varus? The third power. Not negative, because when we bring it down, it becomes positive. And then for the y's, you have 4 y's up here, but 6 y's down here. So these y's are going to cancel with 4 of these y's, and how many will you have left over? No, don't think about negative, just think about 2. I have 2 left, and they are in the denominator. So y squared. And then after that, there's nothing else to simplify. So I'm just going to move the 1 in the middle and make that my final answer. So if you did the subtraction, you're just going to have to, so Cooper, that should have been all in the denominator, and then you bring the y, oh no, never mind. I don't know what you did. Okay, so try part D, because D is very similar to it. And then once you do part D, you can try the word problem also. You say 12?
No, not. I got 1
Oh.
over 3x to the 4th y to the 5th.
You're very close. The x is wrong, though. Okay, so 3/9 becomes 1/3. The x over x cubed, you're not bringing the x down because it doesn't have a negative exponent. You're canceling it out with one of the x's in the denominator. So one of these x's will cancel with one of these and leave you with 2 left over. And then the y's, they do come down to the denominator because it's a negative exponent, and then it adds with the one that's already there, so y to the 4th. So 1 over 3x squared y to the 4th. Raise your hand if you got that all right. Good job. Raise your hand if you got like 2 parts right out of the 3 parts. Okay, good job. 2 out of the 3 isn't bad. And then the word problem says the order of magnitude of the mass of a polyphemus moth larva when it hatches is 10 to the negative 3rd grams. During the first 56 days of its life, the moth larva can eat about 10 to the 5th times its own mass in food. About how many grams of food can the moth larva eat during the first 56 days? So we would just take 10 to the 5th times 10 to the negative 3rd. Brock?
10 squared.
Yes, 10 squared, which is 100. It can eat 100 times its weight. Can you imagine eating 100 times your weight in food in the first 56 days of your life? I don't know. Huh. Anyways, okay, that is the end of this lesson. And you guys can work on homework now.